So expand the term 4a plus 3b power 4 by using binomial coefficients. If you get the path value is least compared to the previous value, you have to write the least value only. So here 2 power n is greater than n factorial. For every integer n is greater than or equal to 4. This is a parent node for these two child and these two child. So this is called as internal node. Welcome back, dear students. I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. So in my previous session, I have discussed model question paper. That is my session 1. And in today's session, again, I'll continue the model question paper. So in my previous session, I have discussed the part A questions. So in part A, you'll be getting 12 questions. You have to attend 10 questions. Each question carries 2 marks. So you can score 20 marks in part A and you can score 60 marks in part B. So in every unit, you will get 2 questions. So you have to attend 1 questions in every unit. So 14th A. So in my previous session, I have discussed 14th first question A, B, C, and now I'll explain 14th next question. So construct the truth tables for the following. For construction of truth table, easily you can score marks in construction of truth table because you will get 3 questions, or sometimes you'll get 2 questions in construction of truth tables. So how to construct the truth table for this PQR, that is P implies Q implies R. First, I'll write the possibilities for P variable, Q and R. So true, 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 false, false, false and false, true, true, false, false, true, true, false, false, true, false, true, false, true, false, true, false. Now, I'll find out inside the parenthesis, I have Q implies R. So, this is simplification. True, true means true, true, false is false. Otherwise, everything is true. True, false is only false. Next, again, I'll find out this P implies Q implies R. So, you just use these 2 columns. P implies Q implies R. That is true, false, true, true, true and true. And the next question is P or negation R. So, first I will find out negation R. So, negation R means opposite of this statement. True is false, false is true, true, false, false, true, true, false, false, true, true, false, false, true. And P or negation R. So, here we are using OR operation, that is addition operation. So, you just use this P and negation R. So, OR operation, if any one of the statement is true, so the final statement also true in OR operation. True, false and true. And the next one is P biconditional Q. So, here both the side you have arrow, that is biconditional. So, in biconditional true, 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 false, false, true, false, false. If both the statements are true, then only it is true, otherwise it is false and false. So, now I'll write P biconditional Q, that is P and Q. True, true means it is true, true, otherwise it is false, 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 true and true. And the last one is P implies Q. So, first you have to find out P implies Q. P and Q. It is true, true, then false. True, false means it is false. Otherwise, it is true, true, true and true. And the next one is P implies or R. OR operation. So, you have to use this first and this is second. Just check this P implies Q and R. So true, true is true, 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 false, true, and this false, true, true, and true. So this is your construction of truth table for 8 marks. Clear? And the next question is, an universe comprises of all real numbers. The open statements P of x, Q of x, and R of x and S of x are given. They have given P of x, Q of x, R of x, and S of x. And here they have given P of x, Q of x, R of x, and S of x. Check whether the following statements are true. Clear? True or false. We have to find out for this question. This is your question. We have to prove that the given statement is true or false. They have given P of x, Q of x, R of x, and S of x. In quantifier, you have universal quantifier and existential quantifier. Two types of quantifiers. So universal quantifier means the symbol is for all, and this is for existential quantifier. So now they have given the statement existential quantifier x, P of x and R of x. So we have to find whether the condition is true or false. So just write the statement for this logical connectives. So I'll write the statement. So now I'll take this existential quantifier for x, P of x and R of x. So now P of x is what? X is greater than or equal to 0. And R of x is what? x2 minus 3x minus 4 is equal to 0. I'll write the existential quantifier for this. Sum x is greater than or equal to 0. Why it is greater than or equal to 0? Because it is a P of x. Sum P of x means x is greater than or equal to 0 and R of x is what? R of x is x2 minus 3x minus 4 is equal to 0. This is existential quantifier. So I'll read this. Sum x is greater than or equal to 0 and x2 minus 3x minus 4 is equal to 0. This is the statement. So the given statement is true. And the second one is for all x, Q of x implies S of x. So for all x means the symbol for all x, if Q of x then S of x. Implication means Q of x then S of x. For all x, if Q of x is true, Q of x is true, then S of x is what? x2 minus x3 greater than 0. So this is a statement for a second one. For all x, if Q of x then S of x. So Q of x means x2 is greater than or equal to 0, then x2 minus 3 greater than 0. This is your complete answer. And the next one is question number 14C. Define the rule of universal specification. So universal generalization is a rule of inference. So already I have discussed this rule of inference concept that states that for all x, P of x is true. For all x, P of x is true. P of x is true for all elements C in the domain. And universal generalization is used when we show that for all x, P of x is true by taking an arbitrary element of C from the domain. This statement you have to mention in a universal generalization. Clear? So this is for 3 marks. And the next one is 15th question. Very, very important question. Definitely there will be a question on this topic, that is binomial coefficients. So expand the term 4a plus 3b power 4 by using binomial coefficients for 5 marks. So already I have discussed this binomial coefficient problems. You have to use the formula a plus b power n. So what is the formula? So NC0 A power n minus 0 and B power 0 plus NC1 A power n minus 1. If you get confused on this formula, you just take this n minus 0 that will go to the power and n minus 1 that will go to the power and B power 1 plus NC2 A power n minus 2 B power 2 plus NC3 A power n minus 3 to B power 3 up to NCN A power n minus n into B power n. This is a formula for finding the binomial coefficients. Very, very important question. Please use this formula for expanding this term. So now, what is the value of A? A is equal to 4A and B is equal to 3B and n is equal to 4. Clear? Now, I'll substitute the value of this n, A and B. You will get the value. So, what is the value of n here? It is 4C0. A means 4A power 4 minus 0. B means 3B power 0. 3B power 0 means 1. Plus NC1. NC1 means 4C1. A value is 4A power 4 minus 1 into 3B power 1. 4C2. 4A power 4 minus 2 and 3B power 2 plus 4C3, 4A power 4 minus 3, 3B power 3 plus 4C4, 4A power 4 minus 4 into 3B power 4. So, till here you have to expand the term. So, 4C4, value of n is equal to 4. So, 4C4, 4 minus 4 is equal to 0. So, till here you have to expand the term. And next is, you have to find the value of 4C0, 4C1, 4C2, 4C3, 4C4. Every time it is very difficult to find 4C1, 4C2, 4C3 and etc. Is it right? So, for that, reducing the complexity, we are using the concept called Pascal's triangle. Pascal's triangle method. So, what is this Pascal's triangle method? So, here Pascal's triangle method. In Pascal's triangle, we are easily apply the value of 4C0, 4C1, 4C2, etc. So, how to find this? I'll use the concept. In Pascal's triangle, it should be in a triangle method. The value will start from 1, 1, 1. And you just add these two values, 1 plus 1 is equal to 2 and the remaining values 1 and 1 is same in edges. And again add this value, 2 plus 1 is 3, 2 plus 1 is 3, again 1 and 1. Again 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4 and 1 and 1. Is it clear? So now how many values got? 1, 4, 6, 4, 1. So totally 5 values. 1, 2, 3, 4 and 5 values are there. Is it right? Now, in place of 4C0, 4C1, 4C2, 4C3, 4C4, I'll substitute 1, 4, 6, 4, 1. This is called Pascal's triangle. So, for reducing the complexity, you can use this concept. In place of 4C0, put 1. And the remaining value 4A power 4 and 3B power 0 is 1 plus 4C1 means plus 4, 4A power 3, 4 minus 1 is 3 into 3B plus, I'll write here, 4C2 value is 6, 4A power 2 and 3B square means it is 9B square plus 4C3 is 4 and 4A power 1 and 3 3s are 9, 9 3s are 27. BQ plus 4C4 means it is 1 and 4A power 4 minus 4 is 0. So, 4A power 0 is 1 and 3B power 4. 3B power 4. So, now you just simplify this value, you will get the final results. Simplify this, 4a power 4. So 4 into 4 into 4, 4 times means it is 256 a power 4 plus 4 into 4 power 3 a cube into 3b. So you will get 768 a cube b plus 6 into 4 square means 16 into 9. So you will get 864 a square and b square plus multiply this, you will get 144 a b cube. So this is your result, and plus 3 power 4 b cube. So 3 into 3 into 3 into 3. So 81 b power 4. So this is your final result. Please use this Pascal's triangle. Easily you can simplify the big value of n. Clear? So sometimes you will get the fraction, example x plus 1 by 2 power 6. You can simplify this by using this formula and Pascal's triangle. And 3x power root 2 power 12. You can simplify this by using this formula and Pascal's triangle. Very simple concept. Please use this Pascal's triangle and simplify this. Expand the term using binomial coefficients. And the next one is, the chairs of an auditorium are to be labeled with a letter and a positive integer. Read the question properly. The chairs of an auditorium are to be labeled. Assume that in auditorium we have chairs. So chairs of an auditorium are to be labeled. It's labeled with a letter. Labeled. All the chairs are labeled with a letter and a positive integer. Positive integer. Clear? It can be 0 to 100, etc. So letter means totally we have 26 letters in alphabetic. So 26 and positive integer, and here not exceeding 100. Positive integer not exceeding 100 means, so only we have 100 integers, positive integers. So the chairs of an auditorium are to be labeled with a letter is 26, positive integer not exceeding 100. What is the largest number of chairs that can be labeled differently? So what is the largest number of chairs that can be labeled differently? That is product rule, 26 into 100, that is 2600 ways. So this is the largest number of chairs that can be labeled differently. This is for 3 marks. So in this type of question, please read the question twice and thrice and understand the logic. Then you just write the possibilities. First you have to read the question properly. So if it is if they have mentioned letter means 26 letters, and if they have mentioned the positive integer, definitely they will mention, so below 100 or above 100 or below 500, they will mention this, and you just use the product rule, addition rules, counting already have discussed, product rule, addition rule and multiplication rule, right? So counting already have discussed, addition rule, subtraction rule and product and division rule. So this is product rule. So 26 into 100, 2600 is the largest number of chairs that can be labeled differently. And the next one is, a professor writes 10 discrete mathematics true or false questions. A professor writes 10 discrete mathematics true or false questions. So how many questions are there? 10 discrete mathematics questions. Out of that, we have true and false. So how many possibilities are there? Only 2 possibilities, that is true or it can be a false. So here 10 discrete transformation questions are there. So out of that we have 2 possibilities. It can be true or it can be a false question. In this question 6 are true. 6 are true means, and the remainings are 4 is false. Is it right? So totally we have 10 questions in discrete transformation. So 6 questions are true. They have mentioned that 6 are true, and the remaining questions will be false only. So the remaining is 4. So 4 false and 6 true questions are there out of 10 questions. If the questions can be positioned in any order, how many different answer keys are possible? So 10C6, clear? So totally 10 questions are there. So we have 2 possibilities. Out of 10 questions, we have 6 questions, true questions, and how many possibilities are there for answer keys? So 10C6 divided by 6 factorial is the correct answer. So 10C6 and 6 are true. If the questions are positioned in any order, so you can arrange this true, true or false. So that means 2 true questions and 1 false questions. So how many ways you can arrange this true 2 questions and 1 false question? So true, 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 false, true, and false, true, and true. So now 3 into 2, that is 6 factorial. Is it clear? So this type of question you can expect for 7 marks and 5 marks and 4 mark also. Please practice permutation and combinations and pigeonhole principles problems properly. So easily you can score in permutation and combination problems. So read the question properly, understand the logic and find the answer. And the next one is use mathematical induction to prove that 2 power n less than n factorial for every integer with n is greater than or equal to 5. So every integer value is greater than or equal to 4. So definitely there will be a problem on this question, mathematical induction. So first step is S of n, write the given condition 2 power n less than n factorial, right? So this statement is true. And in mathematical induction, you have 2 steps, that is basis step and next one is induction step. Basis step and induction step. So what is this basis step? So here I'll replace the value of n. N is equal to 4. So 2 power 4 less than 4 factorial. What is the answer? So 2 power 4 is 16. So 4 factorial means 4 into 3 into 2 into 1. So 16 is less than 24. Is it right? Yes, the condition is true. So in basis step, you have to prove that the condition is true. So 16 is less than 24. So 2 power 4 less than 4 factorial, the statement is true. And in induction step, so you have to prove that k is true. Clear? So now in place of n, I'll put 2 power k less than n k factorial. This is the equation number 1. 2 power k less than k factorial. Replace n by k. So in induction step, you have to prove that k is true. So 2 power k less than k factorial. This is the equation number 1. So for every integer, k is greater than or equal to 4. So I have replaced n by k. K is greater than or equal to 4. And next step in induction method is k plus 1 is true. You have to prove that k plus 1 is true. Is it right? Now 2k plus 1 less than k plus 1 factorial is true. So in place of k, so in equation number 1, in place of k, you just replace by k plus 1. So I'll take this 2 power k plus 1. I can write 2k into 2 power 1. Clear? 2 power k plus 1 means you can separate the power value 2 power k into 2 power 1. So now in place of 2 power k, you can write it is k factorial into 2. Is it right? And here k factorial means I can write k into k plus 1 also. This is a rule. K factorial is equal to k into k plus 1. So I'll write k plus 1 into k factorial. So k factorial means k plus 1 into k factorial because n is greater than or equal to 4. And now I'll write the answer k plus 1 factorial is true. So here 2 power n is greater than n factorial for every integer n is greater than or equal to 4. So this is your statement. So this is your proof. In mathematical induction, you have to prove that S of n is true, k is true and k plus 1 is true. That is basis step, and you have to explain the induction step. Please explain the step properly. Definitely you can score in mathematical induction. And the next one we have, there are 32 microcomputers in a computer center. Each computer has 24 ports. There are 32 microcomputers in a computer center. Each computer has 24 ports. 24 ports and 32 microcomputer. Just observe that here you have to use the pigeonhole principle because the number of ports is less than the number of computers. Is it right? So 32 microcomputers are there, but the number of ports are 24. So now how many different ports to a microcomputer in the center are there? So how many different ports to a microcomputer in a computer center? So here you have to use the pigeonhole principle. Pigeonhole principle. So m is greater than n. Here the number of ports is greater than the number of microcomputers. Is it right? So just use this pigeonhole principle. We have to use p is equal to m minus 1 by n. This is a formula. So now m is greater than n. The number of ports is greater than number of computers. That is m is greater than n. So m is equal to 32 and m is equal to n is equal to 24. So now I'll substitute the value here. So m value is 32 minus 1 by 24. It is 31 by 24. This is the value of p. P is equal to 31 by 24. And now finally you have to substitute the value, that is p plus 1. So p plus 1 means what? What is the value of p? 31 by 24 plus 1. That is 31 plus 24 by 24. Take LCM. So it is 55 by 24. So p plus 1 is equal to 55 by 24. Clear? So this is called as pigeonhole principle problems. Definitely there will be a problem on this pigeonhole principle. Please practice this, understand the question properly and use this formula p is equal to m minus 1 by n and p plus 1. Clear? And the next one is compute sigma j is equal to 0 to 8 and 2 power j plus 1 plus 2 power j plus 3 power j plus 2. So here you have to substitute the value of j from 0 to 8. So I'll substitute the value of a. J is equal to 0. So 2 power 0 plus 1, 2 power 0, 3 power 0 plus 2. 2 power 1, 2 power 0 is 1 plus 3 power 2 is 9. So 9 plus 1 is 10. 12 is the answer for this 2 power. So j value is 0. So if j value is 1, 1 plus 1, 2 power 1, 3 power 1 plus 2. So 2 power 2 is 4, 2 and 3 power 3 is 27. So here 31, 27 plus 4 is 31, 31 plus 2 is 33. So every time you have to find the value of j. J is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8 till 8 you have to find the j value. So you will get one term. You just add these values 33 etc. You will get the final result. So this is called computation procedure for summation. And the next one is part B. Last question is 16th question. So in 16th question you will be having A, B and one more choice question. Write the adjacent matrices for the following graphs. 8 marks question. You have X and Y. So first you have to write the given adjacency values A dash, B dash, C dash and D dash. So A dash, B dash, C dash and D dash. So here A1 to B1, A1 to B1, A1 to D1, A1 to C1. It is not a digraph, it is indirected graph. So A1 to B1, 1, A1 to C1, A1 to D1. So the A1 to A1 is not there, self loop is not there, so I have put 0. And B, so here B1 to C1 and B1 to D1 and B1 to A1 also, self loop is not there. And C1 to A1, C1 to B1, C1 to D1, self loop is not there. And D1 to A1 and B1 and C1 also, D1 is 0. So this is your adjacency matrix for this graph. And the next one is A, B, C, D and E. A, B, C, D and E. And now observe this graph. This is not a directed graph, it is indirected graph. A to A, self loop is not there, and A to B, it's connected thrice. First one, second direction and third time. So A to B is 3. Is it clear? And A to C is 2 times. D, A to A is not there, and A to D is not there, A to E also not there. Clear? And next is B. B to A, again it is 3 times. B to C, B to B is not there, B to C is 1 time, B to D is 1 time, B to E is 1 time. And C, C to A is 2 times, and C to B is 1 time, C to D is 2 times, and C to E is not there. And next is D. D to A is not there, D to B is 1 time, D to C is 2 times, and D to D is not there, D to E also not there. And next is E. E to A is not there, E to B is 1 time, and E to C, D, E is not there. So this is your adjacent matrix for a given graph. Please write this properly. It is very easiest concept. And the next one is using Discrete's algorithm, find the length of the shortest path between vertices A to Z in the following weighted graph. So here they have given the weighted graph. So now A to B is 4, A to C is 2, and they have given the graph. By using this graph, we have to find the shortest path between the vertices A to Z. So how to find this shortest path? By using Discrete's algorithm. Very, very, very important question. So definitely there will be a problem on this question, 7 marks question. Easily you can score on this topic, that is Discrete's algorithm. So how to solve this Discrete's algorithm? So first list the given element A, B, C, D, E and Z. A, B, C, D, E and Z. So now you have to find the source value. So you have to find the source. So here I'll take A is my source. So I'll start from the source point A. So all the path start from 0 initial value, that is 0. And for source A, remainings are infinity and infinity. So now A to A is 0 and next A to B. So I'll find out A to B. So value of A is 0. So 0 plus 4 is equal to 4. And A to C. So is there any value for path from A to C? A to C is 2. So it is 0 plus 2 is 2. And A to D is not there, A to E is not there, A to Z is not there. So I'll write as it is infinity and infinity. I'll repeat. So the source value is A. The path starts from initial value, that is 0. So A to B, 0 plus 4 is 4. A to C, 0 plus 2 is 2. So the least value is 2. 4 and 2, the least value is 2. So I'll take the path C. Now, path C value is 2. Already have completed this path A. I'll take path C. Path C value is, least value is 2. C is connected to B. So C to B is 1. So 2 plus 1 is 3. So 3 and 4, the least value is 4. I'll repeat. So C path value is 2. C is connected to B. C is connected to A. Because already have visited this path A, I'll not repeat this again. So it's cancelled. So C is connected to B. So C to B is 1 means the path value is 2. 2 plus 1 is 3. So 3 is the least value compared to 4. So I have written 3. And next is C to D is 8. So 2 plus 8 is equal to 10. So 10 is the least value compared to infinity. So I have written 10. And next is C to E. C to E is 10. So 10 plus 2 is 12. C to E is 12. So 12 is the least value compared to infinity. And C is not connected to Z as it is. I'll write the path value. So among these three values, least value is 3. Is it right? So I'll take the next path, path B. Now the path B value is 3. So B value is equal to 3. So B is connected to C also. C already have visited. I'll not visit it again. B to D is 3 plus 5. B to D is 3 plus 5, it is 8. So 8 and 10, 8 is the least value. So I've written 8. And B to C already visited, and B to E is not there, Z is not there. Again as it is, I'll write. So the least value is 8. So it comes under the path D. Now path D value is, it is 8. Is it right? Path D value is 8. D is connected to E. So 8 plus 2 is equal to 10. D to E is 10. 10 and 12, the least value is 10. I have written 10 is the least value. And D is connected to Z also. So 8 plus 6 is 14. So 14 is the least value compared to infinity. I have written 14. So now the least value is 10. So I'll take this path E. Now path E is connected to Z. So 10 is the least value in path E. So E to Z. So 10 plus 3 is 13. 13 is the least value compared to 14. Listen carefully. If you get the path value is least compared to the previous value, you have to write the least value only. If you get the highest value here, you have to write the least value only. Clear? So this is a concept of Discrete's algorithm. So here the remaining last path is path Z. Clear? So this is about your Discrete's algorithm, shortest path. So next I'll find out the shortest path from A to Z. So A to Z is 13. I'll write the shortest path from A to Z. It is 13. Is it right? So here you have to find the shortest path from A to E. So shortest value is 13. You have to write the shortest route for finding the value of 13. So here I have 13. And jump to the previous value. Previous value, if you get the different value here, you can go to the least value among these two values. I'll repeat. So now I'll find the shortest route for A to Z. Shortest route I am finding. So for finding the shortest route, I'll start from this value. The last value is 13. If you get the different value in the previous value, so here you have 13, here you have 14. The previous value is different. If you get different value, you just compare with the next value. So 10 and 14, the least value is 10. So I'll jump here. So Z to E. And next, again, I'll take this value. And here previous value is different. So again, you just compare with the next value. So 8 is least value. I'll take this as a path. So C to D. And next is 8 is my least value. So you just go back to the next previous value. It is 10. So 10 means the least value is 3. So I'll take this. 3 is the least value. The path value is, it is B. And next is different value. Here you have different value. In this 2 value, the least value is 2. So it is B to C. And next is again different value. Among these values, 0 is the least value. I'll take this as a path. So now I'll write the path value. Here it is Z and E, D, B, C and A. Now Z to E. Z to E is 3 plus E to D. E to D is 2 plus D to B. D to B is 5 plus B to C. So B to C is 1 and C to A. C to A is 2. Add this value. 3 plus 2 is 5. 5 plus 5 is 10. 10 plus 2 is 12. 12 plus 1 is 13. So this is your shortest path and this is the shortest route. Clear? By using this Discrete algorithm, we can find the shortest path and shortest value. Clear? This is about your problem, Discrete algorithm. So definitely there will be a problem on this concept. Please practice this properly. And the last question is, define the following root node. So already in my previous concept class, trees, I have explained the different concepts of trees. So tree means is a acyclic graph. So here you have a hierarchical structure. Is it right? So now this is an example for tree. It's an acyclic graph. There is no cycle. It does not contain any cycle. So this is called as root node. Is it right? So root node and internal node. So here you have one division here. So it is a parent node for these two. It is a parent node for these 3 child. Is it right? And this is a parent node for these 2 child and these 2 child. So this is called as internal node. Is it clear? And siblings. So this is a parent node for these 3 siblings. So this is called sibling, sibling and siblings. And next is degree of vertex. Now the degree of vertex for this root node. So what is the degree of this root node? So it contains 2 degrees. Clear? This vertex contain 2 degree. And what is the degree of this node? So 1 and 2. And what is the degree of this node? 1 and 2. What is the degree of this node? 1, 2 and 3. Is it clear? So you can expect this for 2 marks question also. What is child, parent, siblings, root node, internal node and level of tree and degree of vertex and height of a tree and siblings, etc. And the next question is, define binary tree. If a tree contains 2 division, example here I have root node. So is this binary tree? Yes, it contains 2 division. And is this binary tree? Yes, it is a binary tree. And find the pre-order, in-order and post-order traversals for the given binary tree. So here you have a binary tree. You have to find the pre-order, post-order and in-order. So now I'll find out in-order. In-order means root of the node. Root node should be in the middle. So root node first, and this is called left subtree and this is right subtree. Left subtree and right subtree. Clear? And here left subtree has to come in a first position, root node in a second position and right subtree in a third position. That is called in order. I'll write the graph here. So first is left subtree D, B, E, D, B, E and A, and here it is F and C. So here there is no right subtree. So this is called in order. And what is pre-order? Pre-order. So here pre-order means root node has to be in the first position, that is A, and next is left subtree root node in a first position pre-order. Next is D and E. And next is C and F. This is pre-order. And next is post-order. So pre-order means first root node, next left subtree and right subtree. This is pre-order. And next is post-order. So post-order means first left subtree and next is right subtree and then it is root node. So here it is. First left subtree D, E, then B, D, E, B, and next is F, C and B. This is post order. Is it clear? So this is about your binary tree and in order, pre-order and post order. Very, very important question. That is your last question in your question paper. That is tree concept. Please don't skip this graph theory and tree concept in unit 4 and don't skip this unit 1 set theory. For passing marks, you can study this graph theory unit 4 and unit 1 concept. It is very, very easiest concept. And for out marks, please practice all the complete concepts in every unit. Clear? Unit 1, Unit 2, Unit 3 and Unit 4. So this is about your question paper, model question paper on your discrete transformation prescribed by the University of Mysuru. So dear students, all the very best for your examination. I have explained all the topics in my concept class. If you missed my class, please follow the link below, and also I have discussed one model question paper and I have explained the question paper pattern. Please follow the instruction and prepare well for your examination. All the very best for your exams. Thank you all. Thanks for your support. Take care. Bye-bye. See you.